Hello, class. This is the video for chapter 3. And chapter 3 talks about linear and quadratic functions. And we cover only 3 sections, 3.3, 3.4, 3.5. For this week, we cover the first 2. And then after chapter 4, then we'll come back and cover section 3.5. Now, here, this is section 3.3. It says the quadratic functions and their properties. Quadratic functions and their properties. Now, these are the learning objectives. This video will cover the first 2 learning objectives, and then the second video will have the rest of the objectives. And these are the objectives. Says that graph a quadratic function using transformations. That is, those transformations we'll learn in chapter 2. And they identify the vertex and the axis of symmetry of a parabola. Parabola is a graph of a quadratic function. And then the second video will talk about the rest of what the learning objectives. Okay, so now let's define a quadratic function. A quadratic function is of this form. Okay, f of x is equal to as squared plus bs plus c, where a, b, and c are what? Real numbers, and your a is not equal to 0. Because if a is equal to 0, guess what? This whole thing goes to 0, and then you only have what? F of x is equal to bx plus c, and this is not a quadratic function. So that is why the restriction on the a. If a is equal to 0, we don't have a quadratic function. We have actually what? Linear. Okay, we have linear for this kind of what? Situation. Okay, now the domain of the function is what? All real numbers. Now talk about graph of a quadratic function. Okay, the graph is called the parabola. Okay, so where you have your function f of x, all right, which is equal to ax squared plus bs plus c. Now the graph, how it looks, will depend on what this particular term here, especially the a. Okay, if a is positive and negative, what happens? So we say that the graph, the parabola, opens up, okay, opens upward, or it is concave up if your a is what? Greater than 0. In other words, if the coefficient of the x squared is positive, then we have concave up. On the other hand, if it is negative, we have what? Concave down, or we say that it opens what? Downward. Now, graph also has what we call the vertex and axis of symmetry. Simply, sometimes we call the axis of symmetry and the axis, which passes through what? The vertex. Okay. Now, this is the graph we have. So if your a, like I said, if a is positive, we have concave up, and this opens upwards. It's like a valley. Okay. And then the axis of symmetry passes through the what? The vertex. Now, notice when I say axis of symmetry, that means this axis reacting as a mirror, okay, like it was a reflection in the what? In the x-axis or the y-axis. So the graph will what? If the y-axis is a mirror, is the axis of symmetry, then that's why it's symmetric with respect to y-axis. If it's a different line, which is so going to be of the form x is equal to say a or some k, okay, let me use k so that you don't confuse that with what? The a coefficient of the x squared. Okay, and then the other graph, your opens is concave down. Your a is what? Is negative, and that's how the graph looks at. So one thing you should know that if it is what? Is concave up, then it has what? A lowest point. Okay, remember we will call this what? This will be the what? The minimum. Okay, it will be the absolute minimum basically, and then also absolute minimum. Or it also called the what? The local minimum. All right. So take note of that. We will talk about maximum and minimum in few minutes. Sorry, in the next video. Okay. All right. So 2 conclusions we can draw depending on what? If your f of x is equal to what? As squared. Okay. Depending on the a, some of these 2 happens. Now, if we take the absolute value of what? A, okay, you have your a, you take absolute value of that, and it is increasing. That means if a is greater than 1, 2, 3, or is negative and it is increasing, then we say that the graph is vertically what? Stretch. Okay, so you can have a say -2. If you take it to observer of that, as you take the observer and if that value is increasing, what happens is that it is what? Absolute stretch. Sorry, it's vertically what? Stretch. Or we say that it becomes taller, and as it gets closer and closer to 0, it is vertically what? Compressed. All right, or becomes what? Shorter. Okay, now again, remember, if A is positive, it's going to open upwards. If A is negative, it's going to open downwards. But if we take the absolute values and it's increasing, that's when we have a vertically stretched, and then, or if it gets closer and closer to 0, we have, vertically what? Compressed. All right. Now again, if A is greater than 0, the graph opens upward. It opens up. If it's negative, it opens down. All right. Now here comes, this is a review. Okay, this is a review of, remember, completing the squares of quadratic functions, or they call this what? Trinomials. All right, or trinomials. Okay, so if you want to complete the squares, let's take example. We will use this example again to graph a function. But if you want to complete the squares of this function, f of x is equal to 3x squared minus what? 6x plus what? Plus 3. Now, if you compare this with the function, f of x is what? A s squared plus bx plus c. If you compare that, your a in this case is what? Is 3. Your b is -6, and your c is what? Is 5. Now, as we can see, in terms of what we talk, if a is positive, this is going to be concave or concave up. Well, that's not what we are doing right now, but let us complete the squares. First, the coefficient of s squared, we don't want this, the coefficient of s squared to be what? To be any other number other than what? Other than 1, before you can complete the squares. So what we do is that the first step is that factor the 3 out of the first two what? The first two terms. Okay, so if you factor 3 out of the first two terms, you have what? You're going to have 3, bring it out, and it'll be x squared, then minus what? 2x, right? Plus what? Plus what? Plus the 5. Okay, so if you factor this out, we have this. Then what we do is that we said the step 2, you add, we're going to add to this, okay? We're going to add to that. We're going to add to that. We first will take the half the coefficient of the x here. So that's half the coefficient of the x here. And then we what? We multiply by what? By 3. We square that and multiply by 3. So half the coefficient of that is what? You have -2, okay? And we take half of that, and then we square this. Okay, so what does this value be? You have that. If you take half of that, that's going to be what? -1, and you square, you get what? You get 1. So we're going to add, to what is the parenthesis here? That expression. Okay, and that's what I'm going to do here. You're going to add what? That's the 1 that we got. Okay, basically we can have for, let's say, 1 squared, which is the same thing. Then we're going to, because we are adding, we have to subtract. Okay, subtract 3 times, that is this times that value here. So you get subtract 3 times what? The 1. Okay, so that's step 2. Because we are adding, we have to what? Nullify the quantity that we added, so that we maintain the original what? Function. Making sense? So we first take what? We take this coefficient of x squared. When the coefficient of s squared is what? 1. We take the coefficient of x when coefficient of x squared is 1. Take half of that, and then what? You square it. Then you add. Okay, so what quantity did you add? It's going to be, because we factor 3 out, it will be 3 times the 1. That's why we have that. Okay, so this expression gives us the next one. So when we do that, we factor. So what we have there, we have what? 1 squared, and then we are subtracting 3 times the 1 squared that we have. Okay, that's times the 1. Okay, so then let's factor this. This is 3. Okay, we're going to factor it. If you factor this, you write it x, and then the sign between them. All right, this sign comes to this side, okay, comes to them, and then the 1. Okay, if you square that, you are going to get this whole expression there. Okay, then plus, we have 5 minus 3. Okay, let me change my color so then the function f of x becomes what? 3 x minus 1 squared plus what? Plus 2. Okay, now if I want to check, all right, if I want to check if this is what? This is correct. All right, let's check it here. That is, if I take this expression and square it, would I get the f of x? Okay, which was what? Which is 3x squared minus 6x, was it plus what? Plus 5. Would we get this? Okay, so let's take 3x minus 1 squared plus what? Plus 2. So that is that, and the f of x is equal to this. So this is 3, all right? So if you square this, you have x squared minus 2x plus 1, then plus what? Plus the 2. Okay, so we have 3 times the x, we get 3x squared, okay, minus 6x, then plus what? Plus 3. If you remove the parentheses, then plus a 2. So you see that you get what? 3x squared minus 6x plus what? Plus 5. Okay, so this is exactly that expression right there. Okay, when we have this, so we have put this in the form, okay, this is of the form what we call the vectors, okay, the vectors form of the quadratic function, okay, of the quadratic function. Okay, in fact, we're going to take the general function, which we write ax squared plus bx plus what? Plus c. And then we're going to complete the squares. Okay, we're going to complete the squares. Now here we can talk about a lot of things. We can talk about the vectors, the axis of symmetry, once we have it what? In this form. Okay, once we have it in that form. All right, now let's take that. Now here is where the job complete the squares of this general term. Okay, again, a, b, c are real numbers, and a is not equal to what? 0. All right, so we want to take this expression, going through the same steps that we just did. Okay, I'm going to write the f of x. Okay, let me erase that. I want to have a clean. Okay, let's write f of x in the form ax squared plus bx. I'm going to space this out, the c this way. All right, now because the coefficient of x squared is not 1, because since you don't even know what it is, we're going to factor a from what? This the first 2 terms. So write this out, we'll bring out the a, they have as squared. If you have this, they have divide this, the b over what? Ax. So that when you what? When you multiply the a out, you can see a times a squared will give me a squared, as squared. A times b over a, then the a's will cancel and get over bs. All right, that's why we divide by that. Now, what we do is that we're going to look at this part, okay? We'll take half of that and square. So half of b over what? A, okay? And then we square this whole thing. And that's the quantity that we're going to add, okay? That's the quantity that we're going to add. I'll change the color. That's the quantity we're going to add. So if we simplify this, okay, we to simplify what we have here, this will be what? This will be squared over 4a squared. Okay, 4a squared. So what we do is that we're going to what? We're going to add, okay, if you like, you have b over the 2a and square that. Because if I simplify this, this is going to be what? B over what? 2a all squared, right? Okay, so we're going to add and then we subtract that quantity, same quantity, all right? Okay, so I'll write in the second step, and so that you can see that well. We have what? A x squared plus b over ax, okay, So we're going to add some quantity. Let me change the color again. Okay, we have what? B over what? 2a all squared. Then we have C minus, what do we add? Okay, the quantity go, there's A times that. This will be what? A times the B over 2a all squared. So what would that give us? We have what? A x squared, okay, plus B over A x, then plus what? B over 2a, okay, all squared. Then plus the C, what we have there will be C minus what? If you square A over 2a squared, you have A times B squared over 4a squared. Okay. And let us go to the next slide, get more space there. Okay, let's rewrite our function. The f of x is now a x squared plus b over a x, then plus the b squared or b over 2a all squared, all right? All squared, then we put a parenthesis, then plus c minus b squared over what? 4a. All right, so now we're going to express this, simplify the whole thing. If you factor, okay, we factor, we have for a, x, then we pick this guy, one of these, okay, the sign between them, we write what? B over 2a, and the sign between them is that, plus, and then squared. Then plus what? C minus b squared over 4a squared. Now let us simplify, take this part and simplify. C minus b squared over what? 4a squared. Okay, to have a common denominator, we're going to multiply this by what? So this is a, not a squared. Okay, 4a. We multiply this by 4a, and then we divide by what? 4a. So they have a common denominator. So that is equal to this part, okay, is equal to 4ac minus what? B squared all over what? 4a. All over 4a. All right. So then if we factor this, this would be, will be a times x plus b over 2a all squared, then plus what? 4ac minus b squared over what? Over 4a. Now, we're going to write this in a certain form, that a x, all right, and we're going to put minus, then minus b over what? 2a, then plus what? 4ac minus b squared over 4a. Now, we're going to replace this by a certain variable, and then this also term by another variable. So we're going to write this as what? A x minus h all squared plus what? K. So in this case, your h is equal to minus b over what? 2a, and then your k is what? 4ac minus b squared over what? 4a. Okay, so when you put the quadratic function, your f of s in this form, okay, this is what we call the what? We call the vertex form. That's a vertex form. Okay, that's a vertex form. And in fact, that is in the next slide. Complete the squares of what? Of the original function, okay, a f of as squared plus bs plus c. We put in the vertex form like that. And then there's a lot of information we can get from this. All right, so here is what we just did. What we did, we complete the squares of this expression, this function, quadratic function. Then we get this, f of s is equal to a x minus h all squared. Now, your x, h is that as we have just expressed. This is a vectors form. So what do we get from that? Okay, there are a couple of things. All right. One, your vertex, okay, the points, the coordinates of the vectors, the s coordinate is the h. This is actually what? This is h, comma, f of what? F of h. That's what it is. Okay, h, comma, f of what? F of h. Okay, you will notice that the f of x, f of h is actually is the same as what? The k. All right, f of h is the same as what? The k. All right, so that means that your vectors is what? H and then what? And k. Okay, so the vectors is h, h, k. All right, where in this case your k is equal to the f of what? F of h, basically. All right, now the axis of symmetry is a line. Okay, remember this is what? This is equal to h. Is a line x is equal to k. Sorry, h. X is equal to h, which is what? What is h? H is what? B over what? 2a. All right, and then the parabola is concave up, as we said. All right, if it's concave up when a is greater than 0, then the vectors is what? Is a minimum point. If it is a concave down, your a is negative, and it is what? A maximum point. So that means that the y coordinate will either be what? The maximum value or the minimum value. Okay, so this is what I have here. If a is greater than 0, the minimum value is what? Is k, and which is equal to what? F of h, which is the same as f of 4 minus b over what? 2a. Now remember, the h is what? The s coordinate of the vertex. Okay, and then if it is a is negative, then we have what? A maximum value, which is the k, which is the same thing. Okay, the same expressions, but it depends on what the a is. If a is positive, we have what? Minimum. A is negative, we have what? Maximum. All right, so now here is the same expression that we got. All right, remember, we complete the squares of this expression, which is 3x squared minus 6x plus what? 5. Now we want to use that and find the vertex and the axis of symmetry. Okay, so recall from the example that this is how we got. So in this case, what's my vertex? My vertex has a coordinates, which is what? In this case would be 1, and then what? And then 2. Okay, where in this case your h is what? Is 1 because it's minus, and then your k is what? Is 2. Now what's the axis of symmetry? Axis of symmetry is what? H is equal to what? H, and that is what? X is equal to 1 because your h is equal to 1. Okay, so from that, if we ask you, give you an expression, a quadratic function like this, and they ask you to find the vectors and axis of symmetry, remember there's a lot of work. It means that you have to put it in this form, into the what? The vectors form. Okay, there's one way to do that, to the vectors form, and then what you do, you what? And that was you can get your vectors and the axis of symmetry, or you can use a formula. Okay, you can use a formula. Let's see what I have. Okay, I can use a formula to get that. If I want to use a formula, okay, remember my vertex is equal to what? Has a coordinates, your h and then k. All right, now in this case, what is my h? H is what? Minus b over what? 2a. Now according to this, your a is what? 3, your b is what? Minus 6, and then your c is what? Is 5. So if you substitute, this will give you minus what? Negative 6, okay, divided by 2 times what? 3. And I get what? 6 over 6, and that gives me 6 over 6, and that is equal to what? Is equal to 1. That's why we have got the h to be that. Okay, what is your k? K is what? The formula 4ac minus b squared over what? Over 4a. Now, what is it? This is what? 4 times 3 times what? Times 5 minus 6 all squared divided by 4 times what? 4 times 3. Now, if you have this, this is definitely 4 times, 12 times 3 is what? Is what? 60. Okay, 12 times 5 is 60. Then minus 36. Okay, divided by what? Divided by 12. Okay, so this will give me 24 divided by what? 12, which is what? Which is 2. So we got what? 2 as your answer. All right. So that's what 2 ways to find. Whether you put the what? You complete the squares of the original function and get your vectors h and k and get it there, or you use a formula as we have described. All right. Now you will also notice that you also know that your k, we said that k is equal to the f of what? Minus b over what? Over 2a. Okay, which is the same as f of the h. Now let's substitute that. So that means you have 3. This is f of 1. Okay, 3 times 1 squared minus 6 times 1 plus what? Plus 5. This will give me 3 minus 6 plus 5. And that will give me what? It'll be 8 plus minus 6 is what? Is 2. See that? So your k is the same as what? That is your k. It's the same as that. So there are a couple of things that we have done here. All right. We have used the what? We put this in the vectors form, the original function, and then got our vectors and the axis of symmetry. Or we use the formulas, okay, to get the what? The vectors, the h, and then the k. Or we say that the k is what? Is the f of 4 minus b over what? Over 2a. And then when you use that, we get the same k. So I've shown a couple of things there. All right. Now, here is an example. Say we should use transformations, okay, to graph this function. Same function there. All right. We have put the function into what? The vectors form. All right. So first, we draw the graph of what? The basic function, which is y is equal to what? S squared. What does it mean? So we have this, means the h means that we what? We move it to the right. Okay. It's going to be, we have x minus 8, x minus 1. So this will be right shift. Okay. Okay, 1 point, 1 unit, or if you like. And then we multiply by 3. That will be a vertical stretch by 3. And then we move it up. So you're going to go up what? 2 units. Okay. So these are the following transformation. We have the basic, and I'm going to shift it to the right. Okay. If you shift to the right, you have this. Okay. If you shift to the right, it's going to come to the vectors point will be what? Will be 1, 0. And then the y coordinate will just remain the same. The s coordinate will add 1 to them. So that's why we have this point. Then the next step is that, okay, we have multiply by 3. It's going to be what? We're going to stretch it vertically. So it's gotten taller, all right, by what? By 3, meaning that the s coordinate will stay the same, but the y coordinate will multiply by 3. So 3 times 1 will give me the point 23. And then you have 1 times 1, you get a point 02. This point stays the same because y coordinate is 0 and times 3 is 0. All right, and then finally, with this whole, we take the what we have, we move it up 2 units, okay, and that gives us this graph. Okay, we move everything up 2 units, and then we get this graph right here. All right, now that's my axis of symmetry. You notice that? Now look at this point. Okay, the axis of symmetry. Look at this point. Okay, you have, this is 1, you move it, that's 2. And then if you go back, if you go to this side, to the right, you have this point right there. So if I know 1 point on this graph, and I know axis of symmetry, I can use a reflection to get the other points. All right? Okay, here is example 2. It said locate the vertex of a parabola without graphing. Locate it without graphing. Okay, so we have a function is what? F of x is equal to minus 2x squared plus 8x minus what? Minus 3. We want to locate it without graphing, and want to know the concave, whether it's concave up or concave down, and is it maximum or minimum. Okay, so first, as we compare this to the original function, okay, my a is what? -2. My b is what? 8, and c is equal to -4, -3. Okay, so we locate the vectors and the axis of symmetry. Very good. Without graphing, right? So the vectors is what? Is your hk. h comma k. This is your vertex. Okay, now this is the same as what? F of the point is going to be minus b over what? 2a, and then f of what? Minus b over what? 2a. Okay, so this next case, my h is what? Minus b over 2a. That's what you do. Okay, that's minus 8 over 2 times what? 2 times minus 2. So this gives me 8 over 4, and that is what? That is 2. Okay. Then what is f of what? Minus b over what? 2a, which is the same as f of what? F of 2. F of 2 give you minus 2 and 2 squared. We substitute into the original function, plus 8 times 2 minus 3. Let's simplify that. This will give us 4 times negative 2, that's negative 8, plus what? 16 minus 3. Okay, and this gives me 5, because we have what? 16 minus 86 is 8, minus 3 is what? Is 5. Okay, so what is my vertex? My vertex is what? Is a point with a what? Coordinates 2, 2, 5. Okay, now notice that this is my k. All right, the k is what? Is 5 in this case. All right, what's the axis of symmetry? The axis of symmetry is what? Let's call it the axis. Is going to be, is of the form x is equal to h. And this case is what? X is equal to what? It is x is equal to what? The 2. This is my axis of what? Of symmetry. Okay, is it concave up or concave down? Well, as you say, is the concave up? It depends on that. Now, since, okay, a is negative, is less than 0, okay, f is what? Concave forward down. Now, if it's concave down, then it is going to have what? A maximum value. Okay, that means the graph going to be like this. Okay, so what is the maximum value? Maximum value is actually your k, which in this case is 5. Okay, so your k, which is 5, this is your maximum value right here. Okay, so we have the vertex, which is that. And then we have the what? The axis of symmetry, which is x is equal to what? H, which is x equal to 2. All right. So I've done everything there. That's what we didn't write this what do you call it? Yeah. So that makes sense actually. Okay. The second example is what? Is locating the vertex. If we put all this together, okay, what we just did here, if we did it step by step by erasing all, I can have this. Okay, we're gonna take everything and then we do it step by step again so that you can see what is going on. All right, so we're gonna have everything like that. I actually forgot that I have to. All right, so first let's find the x coordinate of the point again. Find the x coordinate of the point, which is equal to h, and that is minus what? That's minus times 8 divided by 2 times a, which is minus 2, because your a is what? Negative. It's right. A is negative 2. All right. So now let us put this everything in perspective actually. So this is equal. That is equal to what? 8 minus 8 over what? Over. Okay, that's minus 8 over minus 4, and that gives us what? That gives us 2. All right, so there was the y coordinates of the point. Okay, the y coordinate is that it is k is equal to f of that, and this is what? F of the negative 4, that's the 2. That's what we just calculated. So we have what? Minus 2 times 2 squared plus 8 times 2, then minus 3. All right. So this will give us the 8, negative 8 plus what? 16 minus 3. And that's the 5 we got. All right. So that gives us everything there. And we have that. Okay. What's the vectors is as we got is equal to what? The 0.25. And then the axis of symmetry is S is equal to what? The H, which is 2. All right. Which gives me this one. And so this one, we said that this is a is equal negative 2 is negative, so the parabola is concave down, and therefore what is the maximum value? All right, again, the maximum value is what is equal to the k. This value here is equal to 5, which is the k. Okay, all right. So now the function is concave up and has a maximum value. And as we said, this is equal to what? Is equal to 5. So this is the end of what? The video for part 1. We'll come to part 2 in a minute. Thank you.